Climate change is an existential threat to humanity. There are many global collective efforts to address the impact of climate change, such as the United Nations Sustainable Development Goals, or SDG. Country authorities are implementing TCFD standards to address climate change issues. From actuarial science perspective, how does TCFD work and how can we contribute? This is the TCFD approach. It focuses on the financial sustainability of corporates. It introduces a concept called transition risk, which quantifies the impact of climate change. In essence, it is about earnings volatility and solvency. This is an illustration of transition risk. Due to globalization, corporates have profit and cost mismatch across countries. The impact of such events exposes a corporate to solvency risk. From actuarial science perspective, all this refers to the loss distribution. Loss distribution helps us to estimate capital adequacy at a certain confidence interval. Many banks adopted 99.96% confidence interval. The remaining expected shortfall is a risk of insolvency that we need to accept, commonly known as a tail probability. The first component of capital adequacy is expected loss, which is included in business budgeting and is reflected in risk-based pricing in products. An example in Basel II and Basel III for credit portfolio is that EL equals to PD times LGD times EAD. In general, it relates to the earnings volatility of a company. Solvency is addressed by budgeting for economic capital, which measures unconditional unexpected loss. One approach is stress testing, which focuses on conditional expected loss in reference to scenarios selected through scenario analysis. This is well documented by UK banking regulators in a Climate Financial Risk Forum. This is an example of stress testing on earnings volatility. This is the earnings distribution without stress and under stress. The skewness and kurtosis under stress changes the characteristics of earnings volatility. Take Singapore as an example for TCFD implementation. Singapore Central Bank MAS has embedded TCFD in its environmental risk management. Singapore Stock Exchange has embedded TCFD in Rule 711A and B. Together, they implement the capital allocation framework towards sustainable economic activities. Through listing rules, SGX governs all listed companies that require capital. Through capital market license, MES governs the three capital market players. Asset managers inject capital, and banks provide liquidity funding for companies. Insurers provide options for risk transfer. Regulations mandate environmental risk assessment and disclosure for all capital market activities. This shapes corporate behaviour towards sustainable economic activities. Capital investment and liquidity funding is where a sustainable future is created and funded. For example, in 2021, MES deployed $1.8 billion of official foreign reserves for climate-related investments through 5 designated asset managers, such as BlackRock, Schroders, and BNP Paribas. Looking at the landscape of the actuary profession, according to IAA, there are about 40,000 actuary fellows worldwide. According to US government statistics, more than 75% of actuaries are working in the insurance industry. And according to SOA, less than 5% of actuaries are working in investment and banking. Let's look at our peers, CFA and FRM. There are about 160,000 charters from CFA and 77,000 certified FRM. Both of them are working directly in the areas of asset management and banking. From sustainability perspective, actuaries should consider repositioning themselves to stay relevant to the world's agenda. There are 3 main areas in prediction analytics, namely prediction methodology, software and tools, and data. Advancements in technology such as AI in Industrial Revolution 4.0 will obsolete and replace some skill sets, and there will be demand for new skill sets. Actuaries need to embrace these changes and upgrade and reposition themselves to stay relevant in Industrial Revolution 5.0. There are 2 main prediction methodologies. In analytical prediction modeling approach, we have preconceived logic for the prediction, and we try to simplify the world to fit into the limitations of the model. Take time series prediction as an example. It evolves from autoregression as a base model to ARMA, ARIMA, SARIMA, and SARIMAX, which are all based on the same idea that the past values of a time series can alone be used to predict future values. In deep learning models, it is a different approach. It is a generic learning algorithm that does not require prior knowledge. It learns and builds a model based on the given data. This is the design of a neural network. This is a deep learning model I made using Python and TensorFlow some time back. There are 122,000 hyperparameters to build a predictive model for very complex nonlinear systems. In terms of software and tools, the common ones are R in RStudio and Python in Anaconda and Jupyter Notebook. With technological advancements, making predictions will not require coding. These are some examples of no-code prediction. We give AI instructions in human language and AI makes predictions. In this Mona Lisa example, AI makes predictions through extrapolation. In this end-of-the-world example, AI makes predictions on non-existent scenarios. And in this cat and dog example, AI makes predictions using transfer learning. In Industrial Revolution 5.0, prediction capabilities will be irreversibly replaced by AI. The basic assumption in prediction models is that history tends to repeat itself in the near future. In building prediction models, we train the model using historical data, we validate the model using out-of-sample data, and we backtest the model regularly. But what if we want to predict events with no historical data? In Industrial Revolution 4.0, generative AI is the solution. Generative Adversarial Network, or GAN, is able to generate random human faces. These people look real, but they do not exist. GAN can be applied for climate change scenario generation and analysis. In Industrial Revolution 5.0, we need to come to terms that many jobs will be irreversibly replaced by AI. As actuaries, we need to reposition ourselves in the new world to coexist with AI. AI can find solutions to complex problems. Our role is to formulate problem statements to AI in areas such as climate change and medical research. With the power of AI, we need to ensure ethical use of AI and implement it in law and regulations. AI is not a legal entity. We need to establish accountability in adopting AI recommendations. The aim is to be controllers, to understand, supervise, and challenge the basis of AI recommendations. For actuaries, we need to find our footing and space towards which we build our bridge.